ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. I want to make this video for you people to understand how to solve simple problems. So these are the examination problems. So first I want to read this question. So try to understand the statements. Based on the statements you will collect the given data. I will read out once. A RCC rectangular beam of 300 into 600 mm overall is reinforced with 3 bars of 20 mm diameter. It is simply supported over an effective span of 5 meter. What is the maximum UDL can be allowed on the beam excluding self weight? Take effective cover 50 mm. Use M20 and Fe500 steel. So if you read this problem, we can say this is a rectangular section and it is singly reinforced beam. So by mistake I have written this doubly reinforced. So this is a singly reinforced beam. Why? Because only one reinforcement is given, that is provided at tension phase. By the statement first itself, this is a RCC, that means reinforced cement concrete, a rectangular. So I have underlined this. So underline this is important. So this rectangular section of size B into capital D. Why? Because in the statement we can analyze whether it is small d or capital D. Overall means, so this is the overall section. So B is anyhow it will be same, but here it may be small d or capital D. Now in this statement it is given as overall, therefore I am taking this as capital D. B into capital D is a reinforced way. So this is the area of reinforcement they have given in number of bars and diameter. 3 bars of dia 20 mm. It is SS means simply supported over an effective span. Effective span nothing but L dash. Here effective span is given. Sometimes they provide clear span with support width. So here directly they have provided effective span. So underline that. What is the maximum uniformly distributed load? That means UDL. Maximum UDL can be allowed on the beam excluding self weight, nothing but we have to deduct this self weight by calculating total weight or total load that is coming on the structure. Take effective cover as 50 mm D dash, otherwise we can assume. So this is adaptable value. Next, use M20 grade concrete and Fe500 steel. So you are mark this. So this is FCK and this is Fy. So by these statements I will collect the given data. It will be very helpful to you people. B into capital D, that is given B 300, capital D 600 mm. I have written here. AST. Before going to that, it can be written in a symbolical form. The bar number 3 bars of dia 20 mm. 3 into area of circle. Normally a rod will be of length. So this will be like this. So a rod length will be maximum, it will be 12 meter. So don't worry. So I am just telling, if you take a section, so this will be of circular in nature. So diameter is known. Diameter is given as 20 mm. So area of circle is pi d square divided by 4 or pi r square. So if you substitute r is equal to d by 2, then it will be same, pi d square by 4. D is known, that is 20. Substitute here and it can be calculated directly. So you can observe here 3 into shift pi into 20 square divided by 4, which is equal to 942.48 mm square. So it is coming 942.4777 something. So I am rounding off here itself 48, or otherwise you can write it as 942.50. It is also okay. Now collect the remaining things. An effective span of 5 meter, nothing but L dash is equal to 5 meter. What is the maximum UDL? That means we have to calculate live load and then dead load. We have to calculate dead load, and obviously we have to calculate total load. By that we calculate dead load. then we will get live load, that is the superimposed load. So this live load is also defined as superimposed load. You have to memorize. So this live load is also, it can be defined or it can be named as superimposed load. Okay, apart from this, effective cover is given, d dash is equal to 50 mm, and FCK is also given 20 Newton per mm square. Don't forget to write units, it's also important. 500 Newton per mm square. So these are the given data. I will so these for just for reference. I'm drawing a line here. Okay. Next, first one is first year. Before entering into the problem, so we have to know some steps. So from IS 456 2000, we have some formula. So I will check whether this is under reinforced, balanced or over reinforced section by calculating neutral axis depth and comparing with axial limit, that is a limiting neutral axis depth. So therefore I will write here to check the section is under reinforced or balanced or over reinforced section. So therefore I have XU by D formula. So I write here, we have XU by D is equal to, so I know that formula, but anyhow for your reference I am referring from IS 456 2000, it is known, I hope you all know this. So refer from page number 96, annexure number G. The formula is given. It determine the depth of neutral axis from the following equation: XU by D 0.87 FI AST divided by 0.36 FCKB into D. So I will just write it here, right here itself, 0.87 FI AST divided by 0.36 FCKB into small d. So here, so I know the value of Fy, I will write here itself, 500 into AST is known, 942.48 divided by 0.36, FCK is known, that is 20, so here it is written 20 Newton per m square into breadth of the section is 300 here into D is not known, so right here capital D minus D dash is equal to small d. So capital D is given 600 minus effective cover is given 50, so nothing but 550 mm. So this will be 550. If you calculate this, we will get a value. So a minute. If you calculate this, so observe the calculator. You will have to select this mathematical mode. Select this 0.87 into 500 into 942.48 divided by 0.36 into 20 into 300 into 550. 300 into 550. You must be very careful while typing in the calculator. So this comes around 9.3451. So this is a ratio, it doesn't consist of any unit. So I will compare with XU limit by D. So this is known 0.48 for 500 Newton per mm square. So this is wrong. This is for 415. For 500 Newton per mm square, I have a value. So that will be 0.46. I will write here itself in order to memorize. for Fy and then XU limit by D. Fy for 250, for 415, for 500. So for 415 everybody knows that is 0.48. So this is 46 and this will be I hope this will be 0.53. So we'll check once what is the value for that. Okay, fine. So this is correct for 250 0.53, 0.415, 0.48, for 500 0.46. Then it will be XU limit by D is equal to 0.46. Compare these two values, XU by D and XU limit by D. So we can say XU by D is less than XU limit by D. Hence, so write the statement, hence the section, so I am writing S by N, that mathematics section is under reinforced. Under reinforced. So this is an important statement. I am underlining this. In the exam, don't use a reading pen. You just mark it by using blowing. Next, so this is one part. Next, I will write here itself. So again, it is continued. After this, by knowing the section type of section, that means we have decided that this section is under reinforced. Then we have to calculate moment. So I will write like this: to calculate moment carrying capacity. So mu is equal to, we have formula. Anyhow, I know that formula, but for your reference, I am referring it from IS 456-2000. So this formula is used to calculate when XU by D is less than the limiting value. Then this formula is used to calculate moment. Mu is equal to 0.87 Fy AST D 1 minus AST Fy B into D into FCK. So this formula is used. Anyhow, so I will write here. So refer page number 96, annex number G. So this can be referred from this. So I hope this is visible to you people. So I will write here itself 0.87 FYAST into D 1 minus FYAST divided by FCKB into small d. So now substitute the values. So in examination, according to scheme of valuation, you have marks for each step. 500 into AST, so I am referring from this page. So this is 942.48 into small d is 550 mm. So that is known to you. So this is already calculated. This is 550 mm. And then 1 minus, so observe the formula carefully, 1 minus total value. So you put a bracket here, Fy is 500 into AST 942.48 divided by FCK is 20, B is 300, small d is 550. Close the bracket and again you have to close another bracket. So now use the calculator very carefully. So I hope this is visible to you now. 0.87 on 0.87 into 500 into 942.48 into 550. I hope this is visible. Okay, 550 into, so put a bracket here. So I am placing like this, 1 minus, so this can be written like this also. So don't miss the brackets. 500 into 942.48 Again, what you have to do, come to the this one denominator, 20 into 300 into 550. So close the bracket, and then you have to close another bracket that is already open here before 1. So therefore equals, it will be like this. I will write the whole value without adding any powers, 88605. So what we have to do is just press engineering. So this will be better for you to write in easy way. So I will write like this, 29 into 10 power 6. So these all are in Newton as well as in millimeter. So this will be like this, Newton millimeter. You can write this in another form, 193.29 kilonewton meter. So this can be written like this or this, 193.29 into 10 power 6 Newton millimeter. So this will be in kilonewton meter. So this value can be written like this. So just underline this. So what I will do, mu is equal to this much. So again, instead of this you can use another formula. I will write here itself, 0.87 Fy. So I will write here R. So this is an option left to you, 0.87 Fy AST. So this is stress and this is the area, that is force into distance. So distance, just a minute. Distance is d minus 0.42 xu. So what it is, in the class I have explained about the stress block parameter. So in the stress block parameter I have deduced an equation for this. So if you provide reinforcement here at the center, a force will be acting, that is T, the tensile force, and this will be compression phase, and the stress variation will be like this. I hope this is known to you people. This will be 0.42 xu, and here the compression force is acting. So the distance between these, it will be from here it will be small d, that is effective depth minus this. So that means the distance is d minus 0.42 xu. So this distance is written here. So these are totally, this will be called as force, that is a tensile force acting, 0.87 Fyast. So this is the force and this is the distance. So moment is nothing but force into distance. So this can be written like this. So this is force nothing but tensile force, capital T, into a lever arm or D. D nothing but here it is a lever arm. Don't confuse again. So this is a lever arm. So this is a lever arm and this is a force. Multiply this. So we will get same value, 500 into 942.48 into D is 550 minus 0.42 into xu is known. So that is already calculated, and I have to check the section whether it is under reinforced or balanced. Xu by D is known, so I will take this value to calculate. Xu by D is equal to 0.3. So you can see from this page, 0.3451. So therefore xu is equal to 0.3451 into D is 550. So type the value, 3451 into 550. So you will get a value. So here I will write 89.805 means 81 mm. So substitute the value, 189.81. So calculate this value, 0.87 into 500 into 942.48 into 550 minus 0.42 into 189.81. So you will get a value 192.8 kilonewton meter. So just compare these two values. So almost it will be same. So So due to decimal changes or decimal values, while considering we have neglected some part, therefore, so these variation has occurred. So otherwise the values are same. So you can use this formula or this formula. It is left to you. So now I will consider this formula itself. So this is one part of this. So this is extra. So you can calculate mu by using any one formula. So now I will draw a line here. So this is just for reference. Don't draw. No need to draw lines. For your reference I am drawing lines. So after calculating this, I am calculating unfactored moment. So we will call this as I will call in bracket unfactored. So unfactored, which is equal to mu divided by 1.5. So here 1.5 is a factor of safety that is known to you. In concrete and limit state design, we will consider a limit state, that is a factor of safety of 1.5. So the mu is calculated 193.29 into 10 power 6, or you can write directly 10 power 6 divided by 1.5. So we will get a value 193.29 divided by 1.5. So directly we will write this as 128.86 into 10 power 6 Newton millimeter, or 128.86 kilonewton meter. So you can take this value or this value based on the unit. We will consider the value. So this is one part. So now in order to calculate, so next to calculate safe superimposed load fine. I hope this is not visible to you. Now you just see this. We will explain once again. So we will calculate mu, and then after calculating this mu, we will calculate safe unfactored moment by dividing by factor of safety, that is 1.5. That is known to you people from limit state method. It is well known that factor of safety is added. So therefore we are deducting that 193.29 into 10 power 6 divided by 1.5. It comes around 28.86 kilonewton meter. So after calculating this moment, I have to calculate safe superimposed load. Therefore, by using the, see from the next page. So again it is continued. I hope this is visible to you people. Okay, fine. Now, after calculating the moment, so in the problem they have given, the data is given such that this is a simply supported beam. So SS. So therefore I will write a sketch here. So this is simply supported with an UDL. So this is W kilonewton per meter. This length is given L dash. I will write it in mm. So L dash is 5000 mm. That is the effective length given. Continued. So I will take. So we have. So this procedure is followed to calculate safe superimposed load. We have formula to calculate the moment. Maximum bending moment occurs at the center. So if you project these lines, we will get a bending moment diagram like this. So this is the maximum bending moment. We will call this as mu itself, and the formula is WL square divided by 8. So WL square divided by 8, moment is known, mu is known, that is 128.86 into 10 power 6. If you add 10 power 6, the unit will be in, so observe here, it will be in 10 power 6, then the unit will be Newton millimeter. So have to substitute these remaining values in mm. So W will call this as WT, L is nothing but 5000 square, so this must be in mm, divided by 8. So therefore if I want to calculate WT, so write here 128.86 into 10 power 6. So multiply this value to the numerator, divided by, it comes in the denominator 5000 square. So type the value very carefully. So you can type by using this, or otherwise 128.86 into 10 power 6 into 8 divided by 5000 square. So we'll get a value 41.23 kilonewton. We'll get a value 41.29 kilonewton per meter. So this will be in okay, fine. Okay, fine. So you can observe here, so these moment, if you write the unit, so this will be Newton millimeter. So as you can observe here, so this is Newton millimeter. Newton millimeter divided by mm square. So 1 mm get cancels with power. So this will be Newton per millimeter. So if you this will be millimeter, means Newton divided by 10 power minus 3 meter. So this comes, when it comes to the numerator, it becomes 10 power 3. 10 power 3 into Newton divided by meter. 10 power 3 nothing but kilo. So this will be Newton. So there will be kilonewton per meter. So that's why I am writing here. The total load is 41.23 kilonewton per meter. So after this, I will calculate the self weight of the structure or element, self weight of the section B into capital D. So to calculate the self weight, I will call this as dead load B into capital D per unit length into density of concrete. So here we assume, or we adopt a density of concrete as 25 kilonewton per meter cube. So this is the value we will going to adopt now to calculate this. So I will write it in meter itself, 0.3 into 0.6 into 25. So we will get a value 0.3 into 0.6 into 25. So it comes around 4.5 kilonewton per meter. So why? Because, so again you see the units, so this will be in meter into meter, and again, so per unit length means you won't consider unit, so this will be in kilonewton per meter cube. So here meter cube get cancels with meter square and remaining is kilonewton per meter, the unit is same. So next, what we do, we want to calculate superimposed load. Superimposed load or live load. So we'll call this as W subscript L. WL is equal to WT minus W dead load D. So why? Because W live load plus dead load is equal to total load. So if you want to calculate live load, send this to the right side. So WL is equal to WT minus WD. So the same formula will be formulated like this. WL is equal to WT minus WD. WT is known, so this is 41.23 minus. So WD is known 4.5. So it comes around 41.23 minus 4.5. You will get a value of 36.73 kilonewton per meter. So this is the required answer. Round off this value. It is very important. Now what we have to do means we have to round off the values, important values. This is important, and total load, this is also important. Round off these values, and then in this page this is important, so we will round off here itself. Mu unfactored, so round off this value. This is also important, so I have round off here itself. Okay, after this, in the first page, this statement is very important. You have to write the statement. For this, you have so see, by this, in this scheme of valuation, so according to scheme of valuation, if I give marks, so for D, if you calculate small d, so it carries 1 mark, so this carries 1 mark. And if you calculate xu or xu by d, so these will be for 3 marks. And for xu maximum or xu limit, so this you will get 1 mark. So either you can calculate xu by multiplying d, or you can calculate xu by d or xu by xu limit by d. Both are same. If you write this statement, this also carries 1 mark. Okay, you can observe here, this is for 1, 3, 1, 1. That means for the answer it will be 1. For this formula it carries 1 mark, for this one and for this one. So 1, 2, 3, it will totally it will be for 3 marks. And then in the second page, if you calculate mu and then safe, that is unfactored moment, by calculating this with this, you will get 3 marks. So for formula, for value and this value, it will be for 1 mark. So normally for formula 1 mark, and then for this one now 1 mark, and for this one 1. Total it will be 3. So I will remove this. In the third page, if you calculate a total load, you will get 3 marks. If you calculate dead load, it will be for many marks, just 2 marks, and this is for 2 marks. So you count down the marks. 2 plus 2 4, 4 plus 3 7, 7 plus 3 10, 10 plus 1 11, 11 plus 1 12, 12 plus 3 12 plus 3 15. Somewhere it is missing. Hope 3. So this will be for 1 mark. So then it will be fine. 2 plus 1 plus 3, 3 3 6, 6 plus 3 9, 9 plus 10, 10 11, 11 14, 15. So totally this carries 15 marks. So these are the scheme of valuation will be. Please go through the problem, and if you have any doubts, please ask a query with me on WhatsApp, or you can call directly. I hope you know my mobile number.